Oh yeah, great. 12, how are you today? This is Kamala again, once again. We are doing a series of videos for the Memorandum 2025 Paper 1. And in this video, looking at question 9. Question 9 here. Yes, it says that sketched below is the graph x cubed minus 8x squared plus 5x plus 14. A, B, and the C, they are the x-intercept of the function. D and the E are the turning points of the function. Then they say calculate the coordinates of E. Now our E is a turning point as well as D, and we know that as long as we have the equation for the function, to get our turning points, what do? We normally differentiate and equate to 0. Why? Because we know that at this point, for example, this function, at this point here, our gradient is positive, okay? Our gradient is positive. Are we together? And because of that, our derivative is big. Okay, that is from this point here, like from here, going like this, ne? Gradient is positive, ne? But when you reach point D, the turning point, now here, our M, or our gradient is 0. Gradient is what? Is 0. And it's like this, okay, it's 0 here. And because of 0 gradient, then our derivative, or our function, equals to 0. So similarly, as you go down like this now, our gradient is negative, okay? And so our derivative function is also what? Also negative. Are we together? And then at this point E, a turning point, our gradient equals to 0, okay? So also our f derivative here for the gradient function also equals to 0. And when you continue up here, our m is positive again. Then our derivative function is bigger than 0. So for this matter, I am going to use this one here. So I'm going to differentiate and then equate to 0. So the function given here, it is this x cubed minus 8x squared plus 5x plus 14. So if I differentiate to get my first derivative here, I'm going to get what now? We are going to get here 3x squared, right guys? 3x squared, and then minus 16x and then plus 5, okay, plus 5. Hope we are together, equals to 0, okay. And then now what do we see here? So I have to solve the 3x squared, okay, minus 16x plus 5 equals to 0. Okay, so here, because of the 3x squared here, I'm going to have two brackets here, one with 3x and then the other with just with the x, okay, equals to 0. Okay, so here, what am I going to have here? What do I get here? Anyway, I can also just say this is 3 here and then this 5 here, ne? So the 3 times 1 together with the 5 times 1, all I can say 1 times 5, but because of the negative 16 here, I must make them negative here, okay? So in other words, I'm going to have 3x then x minus 5, okay? This is called the cross method. So from here now, let's get our x values. So from here, either 3x minus 1 equals to 0, which gives us x equals to 1 over 3, okay? Or x minus 5 is 0, which gives us x equals to 5, okay? But because our e, the x value is bigger than the x for the d, so the d must be 1 over, and then for e must be the 5, ne? Okay, so now to get our y value at point E, substitution, okay. Now I'm gonna substitute again here. Where there is x, I'm gonna put 5, ne? And when I do so, what do I get? Calculators substitute for me. So where there is x, we put a 5, ne? So we're gonna say here 5 cubed, okay? 5 cubed minus 8 times 5, then squared, right? And then plus 5 times 5, right? And then plus 14. Okay, so here it gives me negative 36. So our points for E, coordinates for E, we have 5 is negative 36. 5 is negative 36. And I hope we are together, guys. Hope we are together. Let us proceed. Now they say here that for which values of x is the function concave down? Now, guys, if we say concave down, we mean this shape, this one here, that is concave down. Okay. If we say concave up, then this shape here. Now, our cubic graph is made by combining these two concaves. Ne? One is concave down like, and at the point of inflection, we have now the concave up. Okay. So if I can get a x at the point of inflection here, then that x is going to help me to find the x values whether to the left actually, because you're looking for concave down. So here we go. Now the point of inflection, what do? We differentiate again and equate to 0. So looking for the second derivative now. Don't forget about our first derivative here. It was this one here, which is 3x squared minus 16x plus 5 equals to 0. So now we need the second derivative. And I need some space here. Okay, so what do we get, guys? Here, second derivative gives us what? Now, if we differentiate again here, what do we get? That is 3x squared minus 16x plus 5. Ne? So differentiate, we're gonna get our second derivative here. Okay, equals to 6x minus 16. But we said it must equate it to 0. Ne? Okay, so the solving now minus 16 equals to 0. And so our point of inflection x is going to be 16 divided by 6, which gives us 8 over 3. So this 8 over 3 is the point of inflection here. Ne? Now it is somewhere here. Somewhere here. So the x here is 8 over what? Is 8 over 3. It is 8 over 3. Okay. It is 8 over 3. Now see, like I told you before, that this is shape of the cubic graph, ne, which is pointing like this, we say this is concave down. Okay, so there's going to be all x values less than 8 over 3. As you can see, these ones, ne, going this side. That's what we're looking for here. So in other words, the function is concave down for all the x values which are less than what? Than 8 over 3. We say it is going to be all x values less than what? Less than 8 over 3. Hope we are together. Okay, now they say here 9.3. The coordinates of B are 2 is to 0. Use the graph to determine the values of x for which the function multiplied by the second derivative is less than what? Less than 0. I repeat, if point B has got these coordinates here, then they say use the graph to determine the values of x for which the function multiplied by the second derivative is less than 0. So what do we do here in this case? Now before we get our answers here, we need to first find our intercepts here for C and A as well. Okay, so we need to get some space here. Let me first clean up this now. Some space here. Okay, now like I said before, that before we continue, we need to find the x at point C as well. So what do I do here? by solving fx equals to 0. Okay, fx equals to 0 here. So this is my fx here, and because they said b is 2 is to 0, I know that x equals to 2 is a root, and so x minus 2 is a factor. So for that matter, to get this one x cubed, it means that I multiply by what? By 1x squared, okay? And then bx, I'm gonna say b here. I'm looking for this b here with an x. And then because this one is positive 14 and this is negative 2, I must say here minus 7, because negative 7 times what? Times negative 14. So I'm gonna open brackets here. I want to get a value of b, and then I should continue doing what? Should continue solving the equation here to get the coordinates of a and c. Okay, so here to get my b now, I'm gonna compare. If you check what I have here in my original, I've got negative 8x squared here. Now this negative 8x squared, if I may use it as a reference here, how can I get x squared here? I can say this x times bx, okay, gives me bx squared, okay, and then I can also say negative 2 multiplied by x squared, that's minus 2 x squared. So if I group them together, I can say b minus 2, then x squared. Now, if I compare coefficients here, I can see that the b minus 2 equals negative 8. So b minus 2 equals to 8 equals negative 8. And so I can end up getting my b by saying b equals negative 8 plus 2, which is giving me negative 6. So in other words, now I'm solving x minus 2, okay, to get the roots into x squared, okay, then minus 6x now, because my b is now 6, okay, then minus 7 equals to 0. Okay, so in here it means I have x minus 2 into now the factors here. I'm gonna have x minus 7 and then x plus 1. Okay, so from here I can see that now this particular case, my values which I have there, what here? I have x equals to 2, that is a 2 here at b, and then x equals to negative 1. So the negative 1 and x equals to 7, okay? So this is negative 1 at a, and then this is 7 at c here. Okay, so these are the intercepts which I have here. Hope you won't get confused. Let me remove what I don't want for now. Don't want this for now. Okay. All right. So let's check the question one more time here. They said that here find or determine the values of x. Determine what? The values of x for which the function multiplied by the second derivative should give us a negative. Now to do this properly, now our second derivative which we got was what? It was we can get it again here so we can see properly. So here our first derivative is what? It is f first derivative equals 3x squared, isn't it? 3x squared minus 16x, okay, then plus 5. What about the second derivative we're talking about now? So the second derivative now here is given by 6x, okay, 6x here minus 16. As you can see, it's a straight line, guys, of gradient 6, which is positive, and then the constant of negative 16. Okay, now this one here, if I may find the x-intercept, is gonna be this 8. Okay, so if I may draw this line here, which is the second gradient function for the second derivative here, to look like this. Remember, it has got a positive gradient, Let's go to the positive gradient here. So what you guys see here in blue, this one is our second derivative. If I decide to draw it, this now passing through what is through this x for the point of inflection, this here. So if I may do like this now, it's passing through this point here, the 8/3. Hope you guys can see it properly. Okay, now let us analyze the situation. Okay, now what you see here in blue, our second derivative. Okay, and then the one in black is our function f of x. Now, when do we get a negative after multiplying the two? Okay, so here, guys, as you see, from -1 going this way, the function is negative. What about here? Also going to be negative. So negative times negative will give me positive. But I want to get, remember the question says like this. The question says here, it says that we need to find, yes, we need to find the product which is giving us a negative, as you see it here. So if I check from -1 until +2 here, the function is positive. This f is positive. Why is it positive? It is above the x-axis. Above the x-axis. Okay, you can see that, guys, until this in this point here. But then this second derivative, the second derivative here, as you can see, it is and so because of that, it is negative, guys. Let's go to negative y values here. These were positive y values from the function. So when I multiply the negative times positive, I get a negative. So my first answer is going to be from -1 until 2. So here my answer is going to be, I'm going to say from -1, okay, less than x, less than 2. That's my first answer. Or now if you are continuing from 2 up to 8/3, they're all negative because they're all below the what? They're all below the x-axis. But from 8/3 until 7, now the function f is, because it is below the x-axis, negative function f, negative until this point here, until x equals to 7. What about our second derivative? Now our second derivative, now it is positive because it is above the x-axis. So now this positive times the negative, I'll get a negative. So my answer is going to be from 8/3, okay, 8/3 less than x, less than 7. So that's what we have here, guys. Hope we are together. That's our answer for this point 9.3. So we said we have those x values from -1, less than x, less than 2. All other x values from 8/3, okay, less than x, less than 7. So that is it, guys. Hope we are together. If we are not together, please don't hesitate to call us on 0785 222 or you can visit our website, okay, in the link below. Let us continue here. Question 9.4. They say here, for which values of t will the function y equals -11x plus t function at 3 distinct points? At 3 distinct points, okay? Now here, you're going to do like this now. Before I do this, I'm going to show you what we mean exactly. This line has got negative gradient here, and they intersect at plus a positive intercept, intersecting the cubic function at 3 different points. Okay, need to get some space here now. Get some space here now. Oh yes, if you check what we have here, they said that this is the function f of x, this one here which you see. Now the question says that for which values of t will y equal -11x plus t intersect the function at 3 distinct points? At 3 distinct points. Now, this is what we mean. So we have got this point D turning point and a point E turning point. Now, this line here, which you see as y equals -11x plus t, has got a negative gradient. In other words, it looks like this, okay? If I may show you guys here, that line looks like this. Okay, so this line putting in blue is what we're talking about now, this line here. Now this line has got a negative gradient, which is negative 11, okay? And now check this out, guys. As right now, as you see it here now, as you see this line now, it is touching the function at two points. If it's a tangent, it is touching at this point here, at this point here, and this point here. But let me first get some copies here. So we do like this now, and again another one, okay? Like this now. You guys can see at this point here, it's touching at only 2 points. Okay, it's touching at this point here, and then touching at this point here. However, if I continue moving this same line upwards like this now, I move it up, you can see it's touching at 3, okay? Touching at 3 points. Those points are here. There's this point here, this one here. There's this point here, it's touching at E, then touching somewhere here, and touching somewhere here. Then if I continue moving up, here, you guys can see that now, if I continue going up, it's still touching it, but maximum at that other point there is now touching at what? Now touching again at 2 points. Okay. Now with this understanding, what do you have to say? What do we have to say now? Now where the line is touching, okay, check here. Now the values of 2 you're talking about, they're going to be from this 14 here going upwards. So in between 14 and going upwards here. So, but at the point of contact, like here and here, what do we know? That the two functions must be equal. This is y equals to negative 11x, okay, plus t altogether. So they are equal. So I'm going to equate the two functions here. So I'm going to say that my function f of x equals to y, okay, equals to y. So for that matter, the x cubed minus 8x squared, okay, plus 5x plus 14, okay, is equal to negative 11x, okay, and then plus t. Then from here, I can say this is going to be x cubed, okay, this is x cubed, and then minus 8x squared, okay, 11 plus 5, then plus 16, plus 16x here, and then plus 11, okay, plus 11 equals to t. Okay, so this is equation 1. Now to get my t values here, what I'm going to do now, again at the points of in contact, the gradient function equals to negative 11. I repeat, at the point of contact, the derivative of this function f derivative equals to negative 11 because that's a t using equation 1. So, but how do you find this x? Now, at the point of contact, the function, okay, and the lines have got the same gradient. So, in other words, my f derivative here at x, I'm going to equate it to what? To this negative 11, this one here. Equate negative equals negative 11 because they have the same gradient, okay? So, now differentiate, we're going to go to what here? 3x squared, right guys? 3 squared. And then minus 8 minus 16x, differentiating, and then plus 5 equals negative 11, okay? Negative 11. So from here, it gives us 3x squared, minus 16x, then plus 16 equals to 0. Okay, so because of the 3x squared here, I'm gonna have what? I'm gonna have a 3x somewhere multiplied by x, okay, then equals to 0. Okay, so here now the 16, this one here which you see, the same as saying 4 times 4. So if I'm going to use the cross method whereby I need to use this 3 here, that 3 times 1, and then 4 times 4. But the 4, because of negative 16 in the middle term, I must make them negative. Ne? So in other words, if I cross here and add, when I cross, I get negative 12 plus negative 4, which is negative 16. When I say negative 4 times negative 4, I get positive 6, which means I'm going to have here 3x minus 4 and x minus 4 as well. So from here, that my x is going to be equal to 4 over 3, okay, or my x equals to 4. Okay, x equals to 4 here. So now from here, in our equation, we're looking for the t values. So to get our t values here, you're going to substitute now. We're going to put this 4 here into this equation 1. We're going to put a 4 here, also put a 4 here, also put a 4 and get our t. When we are done, then put 4 over 3 as well. So to start with the 4, if I begin with the 4 here, I'm going to have it my t as what? 4, okay? Let's do it together and see here. What do I get from equation 1? So if I put the 4, I'm going to say that I have here, what do I have here? I want to get my t, okay? Yeah, if I put the 4, let's check it. This is going to be 4 cubed here. So this is 4 cubed, are we together? Minus 8 into 4 squared, okay, 4 squared, and then plus 16 multiplied by 4, okay, and then plus 14, it's going to give us what here? It gives us 14. Okay, so here we start from 14, so our first t is 14. Let us now put the 4 over 3, okay. Now if I put 4 over 3 other than the 4, what do I have then? So when I come here now, I'm going to say now 4 over 3, I'm going to say 4 divided by 3. I'm putting 4 over 3, so I'm going to say 4 over 3 cubed, okay. I'm going to say 4 over 3 cubed, and then minus 8 into 4 over 3, okay. 4 over 3 squared altogether, then plus 16 times 4 over 3, then plus 14, it gives me 634 over 7, 634 over 27, okay, 634. So t equals to 634 over 27. If I press SD button, it gives me what? It gives me here 23,48. 23,48. Okay. So now our t values, they're in this range now. So the answer here is going to be our t must lie between 14 altogether, but less than what? Than 23,48. 23,48. Hope we are together. Thank you so much for watching. Catch you in our next video. Bye bye.